our next presentation is, again, something, there's a lot of things dear to our hearts at the moment, and the issue of the welding, the science, the application, the issues are certainly something that's exceptionally critical, obviously, for a civilian armoured vehicle. You can cut the armoured steel, and that's terrific, and thank you very much for Swebor. We saw the issues yesterday. The steel itself, you can see samples, which is excellent. But then if you can't weld it, or if you don't weld it properly into the vehicle, it's not going to be able to create the capability that we're all looking for. So we're with great delight having Chaim Daon, who is a welding specialist and a welding inspector specialist from a company called Archives, who will take us through the story of welding and the processes and the issues that will help you in your technical knowledge. So I leave it to you. Go for it.
Thank you very much, and thank you for letting me join you in this new atmosphere for me, which is the civilian armored vehicles. Now I want to introduce you to my world, which is the world of welding. Get a hold of this. Okay. Welding is everywhere. You can see it in the chairs, in the tables. You can see it in the different machines that are here. The coffee machine has welding in it. And every weld can be considered critical. There's no such thing as a non-critical weld. For example, there's welding in art. The picture on the right, the Chicago bean, is welded, and if something ever happened and that fell, the weld failed, that fell, there would be a lot of damage, a lot of people hurt. Welding in the home. Many of you, I'm sure, have welding machines in your home, and you do little repairs or build things, different projects. Here's a picture of someone building a railing, and if my little grandchild leans on that railing and the weld collapses and he falls, then that weld is critical. The construction industry, many buildings are made out of steel, all require highly professional welders and high professional welding. Piping, gas line, oil lines, water lines, they're all welded. Everything requires qualified welders. We'll talk about that in a bit. Vehicles, cars are welded, trucks are welded, tanks are welded, and armored vehicles are welded, as we see and we know. Welding is dangerous. There are many dangers involved. We'll start because the welding arc, which from electricity, has both sides of the light spectrum. It has infrared and ultraviolet, which can cause many injuries throughout the body. We'll talk about the eyes, which is the most obvious for people welding. So they have helmets. But if people look at, if the welder or people next to the welder look at the welding, then they're going to also have the effect of the burning of the eyes. We call it arc eyes, and that's the name of my company, which is because we look at welds all the time. We hope not to have the problem. But also there are other dangers. For example, most welders work on job sites, and so there are nails. You can see that so you need safety shoes. The weld has spatter, which is metal droplets that come out of the weld arc, and that can burn your skin, burn your arms all over. Luckily, there's technology, and technology has given us answers to to physical safety of welders. For example, we have glasses and helmets. Nowadays, the old days of a welder having to do this movement or this movement to get the helmet down is gone. Now there are electronic helmets that they react faster than the eye reacts to the light. So when the welder strikes an arc, before his eye sees the arc, the welding helmet is already darkened. You have leather coating, clothes, outer clothes to protect, because the spatter from welds will burn through regular cloth. So you have to have leather or similar type of covering on yourself. Of course, you need safety shoes. The fumes from welding will make you sick. So now they have air packs that go along with the welding helmet, and so it sits on a belt, and it brings fresh air into the helmet, and so engineers can be outside watching the weld, and it's very hot, but the welder is cool inside. It's very comfortable. All of these dangers to the welder, technology has been able to address. But there's another danger in welding that we need to address, and that's the psychological danger of welding. I would like you all to close your eyes for a second and picture yourselves putting a cardboard box over your head. And so everything is dark. And all you have to see is a little opening like this. And when you start the arc, all you see is what's through that little opening. The rest is all dark. And you're in constant, your mind and your hands are always in communication one with another, because your hand must be steady, the arc must be steady. Last night you yelled at your children, and now you're sorry about it. You can't let that bother you. This morning on the way to work, the bank called and said, "You're overdraft, you're in a minus in the bank. What are you going to do about it?" You can't deal with that. You heard the news. The news is horrific. You can't deal with that. You have to be constantly in control, relaxed in your mind, and to control your hand, the coordination. That technology has not been able to address yet. Some welders maybe use headphones and music, but that's a rarity. So anyway, so there are problems with welding. There are problems with welders. We will get into now the different types of welding processes that we use. There are hundreds of welding processes in industry. I'm going to talk only about two of them, which is in the main welding that is done for armored vehicles. One is it's called GTAW, which is gas tungsten arc welding, or TIG, which they call it, tungsten inert gas. And the other is GMAW, which is gas metal arc welding, sometimes also known as MIG welding. We'll start with the GTAW. GTAW uses an electrode that is constant. It's a tungsten electrode. What happens is in the welding puddle, molten metal is about 1800 degrees Fahrenheit. The welding arc goes up to about 6,000 degrees centigrade. The welding arc goes up to about 6,000 degrees. And you have a tungsten electrode which will remain constant. It will not burn down. It stays up to about 3,400 degrees. So this tungsten electrode, which conducts the arc, You always will have a weld metal, a metal puddle for molten metal during the arc. And with your, so that's with one hand. You hold on to the torch, and with another hand, you can add filler metal. So it's a two-hand type of thing, type of process, where you have complete control of what you're doing. If we take the machine, as you can see here, the machine comes in various sizes. We'll get into that in a second. Also, I have different pictures of different companies that make machines. I have not one company is better than the other for this. I just used all different companies. Sometimes I've been said, oh, you only have the competitor's welding machine, why not mine? And so I have all different welding machines. If we look at the torch that the welder holds, you can go here. See if this works. Yeah, it works. We can see here, this is the area where the welder, now it doesn't work. Well, this is the area up above is where the welder will hold the torch. We have here, this is the tungsten electrode. And as we can see, if this is the base metal, this will be the arc that the tungsten electrode causes. We also have a gas. Damn, it doesn't work. Well, the gray area is shielding gas. You have one that works? Oh, lovely. Thank you. Okay. Okay. So this gray area is shielding gas. Usually it's argon, but it could also be composition of argon with other gases such as helium, which protects the arc, because what we don't want is oxygen to get into the molten weld metal. We want to keep oxygen out. And here, as we can see, we can add a filler metal. We don't always have to add a filler metal, but we can add a filler metal, which will be essentially the metal that we want to add into the weld. So if we're welding, for example, stainless steel, we will want a stainless steel filler rod. If we're welding armored steel, there are different types of filler rods that are available. We'll talk about that in a bit. Here's examples of welding machines. It can go down to 8 kilogram a machine. You can hold it, no problem, and take it to the work site. Of course, you have to bring gas with you. There are heavier machines which also have water cooling into the torch, so the welder can continue working. Nothing will overheat. And these can go up to 300 kilogram. The advantages of this project, of this process, the GTAW process. First of all, shut this off now. High quality. Because we can use a large range of amperage, we can, some thin metals we can weld with a half an amp, and we can go up to hundreds of amperes. So we have complete control of the work being done. So we have very high quality. We have high deposition. High deposition does not mean high speed. It means that the material, the welding rod material that we're putting into the weld is fully deposited. There's no spatter like you see in movies when you see welding in movies a lot, and you'll see the spatter going all over the place to make it the action movies more exciting. All that spatter is weld metal that's being rejected from the weld pool. So here we have high deposition. For thin materials, we can with or without filler metal. For example, very thin material, 1 millimeter thick, we don't need filler material because the arc will just fuse the metal together. We have excellent penetration. It's very versatile. For example, there are exotic steels. We're going away from armored steels, but there are exotic materials, not steels, materials that you cannot easily get the weld rods, so you can shave off some of that material and use it in the weld pool itself. So it's very versatile. You have total control. There's no slag, what's called, so there's no cleaning involved, and minimum maintenance. The machines are very straightforward. There's no moving parts. The disadvantages, everything has disadvantages. It's very slow. So if you're out to make money by fast welding, forget it. This is not the process for you. And it's also high costs. The equipment is expensive. It's very high. It's very sophisticated electronics in the welding machines today. Of course, you can buy simple ones also for homework or for home projects, but for the welding industry, you get sophisticated weld machines. And the personnel, the welder himself is highly trained. It takes years of experience to get your coordination with two hands and the angles in which to hold, on one hand the torch and the other hand the additional rod. It takes years of experience to get the right angles, and from in this direction, all different sorts of ways to manipulate it. So it's the people are expensive. Yeah. Also, so after we finished with the GTAW, the TIG welding, tungsten inert gas, or gas tungsten arc welding, one is an American way of saying it. The GTAW is the way the Americans call it, and the TIG is the way the rest of the world, the Europeans call it. I say it, Americans and Europeans, but the rest of the world will call it. Then we have GMAW. We finished with the GTAW, now we're on to the GMAW. Let's go back to the machine. And this, not this one, this one. Ah. Okay, here we have this GMAW. It's a little more complicated as far as the machinery goes. So we have a power source, which is this bottom part. And then we have a wire feeder. It's sort of hard to see, but there's a spool, it's usually 15 kilograms of wire that will fit in here. And of course, here you have on the wagon, so you'll have gas balloons, as you can see here in the schema. So here's also the power source, and these two parts are the wire feeder. The spool goes through the wire feeder out into the torch that the welder holds. When the welder presses the torch, presses the trigger, he does a few things. First of all, he opens the electrical circuit. So there is electricity passing through from the wire to the metal we want to weld. He's also opening the flow of gas, because here also we need a shielding gas. We'll go into the different types of shielding gas. And he also starts, or she, so there are female welders, yes. Also will start the wire spool moving. So the wire will, one little flick of the switch, and he starts electricity, the gas opens, and the wire comes through. It's a very fast process, a lot more faster than the GTAW. The majority of manufacturers that are dealing in armored projects are using the GMAW process. Maybe for small items they'll use GTAW, but things like electrodes, welding electrodes, they're more or less passé, although they do exist. The advantages, because there are advantages. We have high quality. We have high deposition. Deposition, again, is the amount that amount of wire that goes into the weld, as far as the amount of wire that goes through the machine. So there is spatter, and sometimes and that will lower the deposition, but it's still considered a high deposition process. You have excellent penetration, especially now they have the welding machines have increased in the technology. The electronics are amazing. They take apart the electric arc, and put it together again 200 times a second. You have pulse arc, you have double pulse arc. It's amazing what you can do with this. So you have high welding speeds. Because the welder will only hold on to the torch and continue with it, you pay less. You don't need a highly sophisticated welder, so the salaries are less. And you have minimal cleaning, because again, the weld is very clean. There's sometimes a slight coating on the weld, but there's no slag that you need hammers and chisels and whatnot. Again, there are disadvantages. It's less portable. The machines are larger because you have the power source and the wire feeder. There's more maintenance because you have moving parts. Inside the wire feeder, there are special wheels that go around, and there's a different wheel for different types of wire and different size wires. And in a normal shop, there'll be a lot of dust, so it can cause problems there. So there's more maintenance involved. You have special gases. We'll go into that, and the equipment is quite expensive. Let's talk about filler metals and gases. Here again, you have two opposing technologies. One is using ferritic filler metal, and the other austenitic filler metal. Ferritic filler is a carbon-based wire, where austenitic filler would be a chromium-based wire. So carbon steel, stainless steel. That's more or less the difference between them. I cannot say which is better and which is worse, or which is better at any rate. They're both good. Each has their advantage. For example, the ferritic filler metal is a lot cheaper than the austenitic filler metal. But the austenitic filler metal has more ductility. So sometimes you decide how you're going to go. You usually don't. Manufacturers do not switch in the middle of welding. They have one way of working or the other way of working, and both are acceptable. Acceptable means that they've been tested, and we'll talk about that in a bit. As far as gases go, the GTAW process, that was the first one we talked about, will use, as a rule, argon gas. And the GMAW will use argon with 2% oxygen or 2% CO2. The difference being, when you have thick material in armored steel is over 15-20 millimeters, then you will use the 2% oxygen, and because it's a hotter, makes it a hotter arc. And when you have thinner material, you can use the 2% the CO2. A lot depends on your client. If the client has pre-requirements of the type of gases to use, then you go with, of course, what the client wants. So, as far as codes go in welding armored steel, there are three major codes that I have found. There may be more, but I've gone through many, many pages of Google to see maybe I missed something, and I have not found anything else. We have from the USA, the Department of Defense, the MIL standard. The IDF is the Israeli Defense Forces. Unfortunately, has a lot of experience, so they have a standard. And there's a German DIN 2303 standard for armored welding. Start with the American. The American Standard 3040A was revised in 2024, so it's up to date. It's 126 pages, qualification, fabrication, welding, and inspection of armor and non-armor steel weldments. It's very comprehensive. You'll get all the information you need as far as welding goes in this code. I'm not going to teach us, we're not having a class on codes today, but I'm just giving you the information that these codes exist. The IDF code is 20 pages. It's welder qualification specification, just for qualifying welders. Tells exactly how and what to do to make a welder qualified. Then you have the DIN 2303, which is welding and allied processes, quality requirements for military products, 25 pages. All three codes more or less have the same breakdown. You start with classifications, and this was talked about, what I've heard today as far as the type of armor needed, the type of danger expected, the type of safety needed, and all that. So there are different classifications, and each classification for each code will guide us in what needs to be done. And then we have qualifications. The codes will explain how to qualify the process, how to qualify the welder. We'll get into the difference in a bit. The USA code and the DIN code go into workmanship. The Israeli code is only for welder qualifications, doesn't go into workmanship. Quality control, what's required of the testing to be done. And quality assurance, what's required of the documentation to be performed after all the other stuff has been done. Now we'll talk about quality, or what I like to say, quality and the lack of it. Because unfortunately, that's usually the name of the game, the lack of it. We'll start, now this breaks into three specific areas, and the more time you invest in the first area, you save in the second area, and the more time you, obviously in the second area, you'll save in the third area. So the first area is before welding. Is there a WPS? A WPS is a welding procedure specification. It's a written instruction to the welder how to perform the weld according to the code requirements or the customer requirements. So a welder must have a WPS at the job site, at his station, in the engineering department, somewhere. It'll all depend on the quality system of the fabricator where this WPS is. And if the welder is aware of it, because there are many fabricators that will say, Joe, I want you to weld with this steel, with this wire and this gas, and you weld over there, and you just do what I say. And there are other fabricators where the drawing will list a WPS number, and the welder will go to a book of WPSs and say, oh, I need this wire and this gas and this amperes, and this, and tells exactly what to do. So when evaluating quality before welding, find out if there's a WPS and if the WPS is qualified, because a WPS is a written instruction, but who's to say it's a correct instruction? So the codes have specific requirements for how to qualify a WPS, what testing needs to be done. I'm not talking about the welder, talking about the procedure that needs to be done so that the weld will be of the required quality. Once we have a WPS and it's qualified, then we can ask if the welders are qualified. Different codes have different requirements for welding qualifications. Different codes have different requirements for the length of the qualification. Some codes call for a welder test every year. Some call for every 2 years. And some non-armor codes will say once is enough, just document that he continues working. All a question of the different codes that you're working to. And also before welding, is there a welding plan? Does the shop know what they're doing? Is there a step-by-step way of welding? Once these 3 items are under control, then the continuation is a lot easier. Because then we go into during welding. And during welding, we'll ask, is there quality control? Is there an inspector on board that sees what the welder is doing? Are the welders working to their qualifications? The codes mention that a welder that does a test in this position cannot weld in this position. So, if we go into a shop and we see a welder working like this and he's only qualified for this, obviously he's not working to his qualification. Are there written instructions? This was talked about before when Rob was talking about quality, so that people know what's expected of them, not just in welding, but in preparation for welding. And is there an ITP? ITP is an inspection test plan, which is a step-by-step document saying what needs to be done, what's the referencing document, who is responsible for making sure it's done. And as a rule, there's a checklist, a sign-off, so that each person that finishes his responsibility checks it off, and it goes to the next step, and it starts from beginning to end. So this is during welding. So we've checked all the documentation, we've checked the qualifications, we've checked that there's quality control. Quality control means that we're looking at the welds. That's arc eyes. We try and look after the arc is finished. We look at the welds, we do visual inspection of the welds, and during, making sure that the cleaning is being done. When you weld thick metal armored steel, you have to do a lot of grinding in between weld passes. Thick metal is anything over 4 millimeters of thickness. You already need to weld one layer, another layer, another layer, and the higher in thickness you get, the more layers, and each one must be cleaned before you put the next pass down. So at the end, we do visual inspection. We'll look to see if there are visual defects. A visual defect could be, for example, a gas hole, oxygen hole, which we call porosity. It could be crack, because armored steel is known for cracks. Once we've visually inspected the welds and accepted the welds, then it goes on to what's called NDT, non-destructive testing, or NDE, non-destructive examination. It could be radiography, it could be ultrasound, it could be what we call liquid penetrant testing. That's the red and white liquids that many of you probably know if you're involved in the welding. And of course, documentation. I didn't pass that on, I'm sorry. I'm looking at it here and I didn't see. So again, visual inspect for defects, non-destructive examination, and documentation. Also, what's important, and this was mentioned in the previous talk, after service, history of failures. It's important for a fabricating shop or for the quality uh, to realize where the mistakes were. And this is where everyone raised their hand and said, yes, I made mistakes. And yes, I've made them over and over again. So, with all this involved, how do we go forward? Well, we have quality assurance for that. Quality assurance in the welding industry breaks into two main areas. One is to have a certified welding inspector, and the other to have a quality system. Certified welding inspectors, there are many different types of inspectors. There's the American Welding Society, AWS, certified welding inspectors, which is one of the leading organizations for welding in the world. You have the Welding Institute, TWI, which is based out of England. The Welding Institute has a program for welding inspectors. To be a welding inspector, you must take a test. Depending on I'll go into the others. Depending on the type of test, the country, the test will be theoretical, and usually you'll be tested to knowledge of a certain code. So with the AWS, it would be a construction code. With the CSWIP, it would be the ISO code for welding inspectors. You have the IIW, International Institute of Welding. They also have a system for qualifying welding inspectors. And in Israel, we have ICWI, which is Israeli Certified Welding Inspector, which we have reciprocity with the AWS. That means the American Welding Society recognizes the Israeli welding inspectors, and Israel recognizes the American welding inspectors. That's not as far as the Americans go, the AWS, that's not just a calm statement to make, because there are only two countries in the world that have reciprocity with the American Welding Society. That's Canada and Israel. So we have welding inspectors. Now we go to quality insurance. Quality assurance is a problem in the welding industry. As a rule, it's a problem. In the pressure vessels and pressure pipelines, there are various codes that define quality systems. In steel construction, there are codes that define quality systems. Armored vehicles does not have, to my knowledge, a specific code to qualify to discuss quality systems. And it's not just armored vehicles, it's the rest of the industry. So we have pressure vessels and pipelines on one side, steel construction on the other side, and everything in between is sort of left up in the air. ISO, the International Standards Institution, addresses this with a code. It's called ISO 3834. Now, many of you are ISO companies. You probably have 9001, which is quality management. The ISO 3834 is not a management code. It's a quality, not a code for quality of. Oh, okay, I'll do it quickly. So, the ISO 3834 is a quality certification for welding manufacturers worldwide. It's internationally recognized and not an individual certification. So it's according to the company, not to the person. There are 5 steps to the code, 5 different booklets. We'll go into it. And it's all about fusion welding. Irrespectively, it's self-contained rules for quality assurance in welding plants. A company certified to ISO 3834 is more in demand than a company that doesn't have it, and we'll go into it. The levels are the booklets. ISO is based on individual books. You have quality levels, which is just general information. You have a comprehensive ISO code, which is what we'll talk about in a second. You have standard, which is for non-crucial weldments. You have elementary, which is for very simple weldments. And then you have documentation. But we'll talk about part 2 because that's what will be important for you people. The code you have to have a quality system that addresses contract review, technical review. Is the fabricator, are you capable of doing the job? That's a technical review. Do you use subcontractors? Do you monitor their qualifications? Is your equipment checked calibrated on a regular basis? Hold on. Do you have welding procedures and personnel? Do you do inspection, whether it's destructive or non-destructive? Do you have work instructions, non-conformances, documentation? All these things show that you're capable of giving a quality project. It shows the effectiveness of your system. It reduces costs for NCR, non-conformance reports. You will have less non-conformances when you have a quality system. It's been shown, and this was on the previous lecture, that mistakes cost money. And when you have a good quality system, yes, it's expensive, but it saves money in the end. To get ISO 3834, the company needs to have a contract with an authorized nominating body that can carry out auditing and certify the company. So it means that the company must have a written quality procedures according to the requirements of the code, and it must demonstrate that it works to these requirements. So it's not enough just to have a lovely booklet listing your quality capabilities and system, but you have to prove to the authorized nominating body that you work to that system. These are things that will help define quality. More and more companies throughout the world are getting involved in ISO 3834, including in America, where ISO in America is not always on the best of terms. But yes, American firms more and more are realizing the importance of the ISO 3834 because it encompasses all the welding industry. Thank you.